Hi guys, I think today it's really important that we review how to find the area of a triangle. We didn't do so hot with the last lesson, and I think that's because we didn't always follow the formula, or maybe we weren't able to identify the base and the height. If we go back to the area of a triangle formula, which you should be writing every time, you'll remember that it's the base times the height all divided by 2. But when I looked at your last homework, it looked like a lot of you guys just took every single number and multiplied it, and then sometimes even forgot to divide by 2. That's not what we're looking for here. When we look at a triangle that looks like this, if we see that we have this line with the square, you need to remember that this here, that looks like maybe it could look like this, a backwards H, or this, a forwards H. This line here is the height. So we're going to plug that in 15. Any line that goes like that all the way to another point of the triangle, that measures the height. If we were to turn this into a rectangle, an imaginary rectangle, we have to imagine, okay, well the height of that imaginary rectangle is this line here. So we plug in 10 for height. Do we use these numbers here for anything? The answer is no. So I do not multiply by 12 or another 12, anything like that. All it is 10 times 15, all divided by 2. Or 75 units squared. So if you get really confused about that, I want you to imagine that you fill in the rest of the rectangle and find the height of that, assuming that this is the bottom of the rectangle. What's the height of it? Okay, here's another example of what I mean. Sometimes you'll run into a triangle that looks like this, where the height is not inside the triangle, but you have this 10 over here, and then you can assume, okay, this length here is also 10. Well, if we write our formula out and start filling it in, we can automatically say, okay, let's say that this is the base of my rectangle, and let's imagine the rectangle filling that in. What would the height of that rectangle be? It's not 10. In this case, it's 8. 8 is the line that's perpendicular, going straight across from the line that's 12 long. It has the little backwards H, it has the right angle sign right here, so we know that's the height of the triangle. So our area of the triangle is 12 times 8 divided by 2. Here's one last example. In this case, we see that our triangle is kind of turned on its side. It's like almost on its head. And we see that we have this line with the H with the right angle sign, and we have 13 and 13. These legs here are not important. The 13s don't matter, because if we're choosing 20 as our base, and we make our imaginary rectangle, we see that 20 is the length of that rectangle, and 5 is the height of it. You can see 5 here is the distance from the base in a straight line to the point on the other side, meaning that 5 is the height. So we write base times height divided by 2. But remember, the 13s don't matter. In fact, I can just erase them so I don't even think about them. Those numbers are just put there to confuse you. Do 20 times 5, all divided by 2, or 50 units squared. Don't get yourself confused by the lines that are here on the sides. They don't mean anything for area.